But in another sense, it actually...
I'm having trouble hearing you.
Guess who just recorded a whole video, but forgot to actually turn the front-facing camera on for the recording? This guy. So we are going to do our best. We're going to run it back. We're going to look at target round 7 and 8. Actually, so what I recorded was just target round 8, but I guess now that I've been through it, maybe I'll go a little bit more quickly and try and get them both done. I don't know. We'll see. But in any case, welcome. Good morning, good afternoon, good evening, good whatever time it is where you are. Welcome to today's Math Minute, the only Math Minute guaranteed to be today and guaranteed to be no more than 10 minutes long. I am continuing to look at these target round questions from MATHCOUNTS Practice Competition 3. Of course, the chapter competition for MATHCOUNTS is coming up this weekend, February 5th and 6th. So we are getting down to the wire here. And I just wanted to continue to look at these target round questions. Again, we can use a calculator, though we don't necessarily need to. 7 and 8 are going to be the last pair of target round questions, and they are the hardest of the target round questions. You can see here we've got two long word problems, and I don't even see any numbers here. I know there are actually numbers in the question. I just mean I don't see any digits. So that's never a good sign. That means it's going to be pretty tough here. In both cases, again, because I accidentally did not hit record, I have read both of these already. In both cases, your instinct might be to try and choose some variables, set up some equations, maybe do some substitution, solve a system of equations, and at least in the case of number 8, I know that's not the best method because, again, I happen to have already been through it. So I want to show you how I would approach number 8, and then again, maybe we'll go back and have time for number 7 as well. An ammonia and water mixture, again, I'm looking at number 8, target round number 8. Fills a 5-gallon container. 80% of the mixture is ammonia, but some of the mixture will be drained and replaced with pure water. If a 5-gallon mixture of 50% ammonia is desired, how many quarts of the mixture need to be drained before the water is added, given that 4 quarts equals a gallon? Well, that's nice of them. They're giving us the conversion there. Express your answer as a decimal to the nearest tenth. So again, your instinct here, and it's not a bad instinct. I'm not saying it's wrong, but your instinct here might be to set up some equations, write some variables. Maybe the variable stands for how much water we have, how much ammonia, although that's actually not a great choice for variables because, in fact, as we'll see in a moment, we know how much ammonia and water we have. Maybe your variables are how much of the original mixture versus how much pure water we're pouring in. That could possibly work. But in fact, they've given us enough information here that we really don't need to use variables. Here's what I mean. So imagine the barrel that we start with, the original mixture. We're told it's 5 gallons. Now, they asked for the answer in quarts, so I think it's going to be easiest if we stick to quarts throughout the problem. 4 quarts to a gallon, of course, means that we're looking at a 20-quart barrel. And this 20-quart barrel is split up roughly between 80% ammonia, NH3, I did not remember that, I looked it up in the last version of this video, and then 20% H2O. Now that one I do remember. So 20% water, 80% NH3, ammonia. But we want to take this and we want to turn it into a different scenario. We want to turn this into a scenario where we have this same 20-quart barrel, of course, but now we want it to be a simple 50-50 mixture. So we want down the line 50% water and then 50% NH3, ammonia. In one sense, it's best to think of this question, I shouldn't say it's best. We really want to think about this mixture in 2 ways. I don't know at a molecular level what's going on here. I don't know if ammonia and water form a bond, and so we would call this a solution, or if it's more like an oil and water situation, and it's just an emulsification where all the little bits of ammonia and water are kind of mixed up, but separate. I don't know what's what. It doesn't really matter because according to the question, this is not like a bin of red blocks and blue blocks, right? We can't just pull out the red blocks so as to change the concentration to whatever it is that we want it to be. We're going to have to pour out the mixture overall, and that mixture is in that 20%, 80% ratio to start. But in another sense, it actually is good to think of this as if there were like blue blocks for water and red blocks for ammonia, because here's what's going on initially. We know we begin with 20% of 20 quarts water. And so that means that we have 4 quarts water, right? And then, of course, the rest of it, the other 80%, the 16 quarts that are left over, must be the ammonia. But again, we want to change this. We want to turn this into a 50-50 mixture. They said after we pour some of the mixture out, what would we have to do to get it to be 50% water, 50% ammonia? So what we want in the end is 10 quarts of water and 10 quarts of ammonia. Now, on the one hand, you can see right away, well, we have 16. We want it to be 10, so surely we can just say, well, let's pour out 6 quarts of ammonia. But this is where the problem goes back to the red blocks, blue blocks. We can't separate them out. That doesn't really work. We're pouring out some portion of the 20%, 80% mixture. And so this is where we need to go back to the beginning and look at the ratio between water and ammonia in that original mixture. It's a 20% to 80% ratio, or of course what simplifies down to a 1 to 4, 1 part water, 4 parts ammonia. And so if I want to pour out 6 quarts of ammonia, how much water would that go with in order to obey this 1 to 4 part mixture? For this, of course, we could go ahead and supply some variables if we needed to, but it's relatively easier here to see that the water is going to have to be 1.5 quarts. So at the same time that we're losing those 6 quarts ammonia, we're also losing 1.5 quarts of H2O. Of course, overall, that means that we are losing minus 7.5 quarts before we start filling it back up with pure water and we get the 50-50 mix that we want. Let's make sure that we did it correctly as we go back to the answers. Ta-da! 7.5 quarts. Of course, to the nearest tenth, just like they said, but that's that. That's how I would approach target round number 8. Without systems of equations and probably without a calculator. Now, could we apply similar reasoning to number 7 here? I don't know. Let's find out. Bill, Phil, and Jenny are siblings. Bill is twice as old as Phil. Jenny is 2 years younger than Bill. And currently their dad is twice as old as the sum of their ages. In 9 years, their dad's age will be equal to the sum of his 3 kids' ages at that time. What is Jenny's current age? This would be a great question for like SAT, PSAT, ACT multiple choice, because they would give you 4 or 5 answers, but the answers are the only possible ages for Jenny that we care about, and so we would actually just plug in that number for Jenny's age and then see which one makes all the numbers work out the way that we want. Of course, this is, a blank. There are no numbers there already. We're going to write the number down, and so we can't actually apply that strategy, at least not directly. We could do some guess and check here, and that might end up being the best way. But let's see. My instinct is let's actually go ahead and set up the equations. So Bill's age is going to be 2 times Phil's age. And then Jenny is 2 years younger than Bill. Whatever Jenny's age, we would have to add to get Bill's age. And so you can see right away, all right, clearly there's going to be some relatively simple substitution going on here. Their dad's age right now is twice the sum of all 3 children. So dad is going to be twice the sum of B, P, and J. I guess I'm going to put a top to the J. I guess there is one interesting thing about this question. In 9 years, so sometimes these kinds of questions have these time frame changes, and we have to account for these time frame changes somehow algebraically. And so I'm just going to write it down right now. In 9 years, we can say dad's age is not going to be twice as much the sum of their ages. It's going to equal the sum of their ages. And so basically what's going to end up happening here is we're going to be getting 2 different equations, one for the scenario right now, one for the scenario 9 years from now, and then those equations should be reducible to 2 variables, and then that's a system of equations that we can solve, either by hand or in our calculator. Most calculators that you're going to be using for this competition have a systems solver built in. But how do we account for the 9 years? Well, dad's age in 9 years is going to be his age now plus 9. That's how I'm accounting for the time frame, D plus 9. And then we don't have the 2 anymore, but we are going to have B plus 9, because Bill or Bob, whatever his name is, he's 9 years older. Jenny is 9 years older, and Phil is 9 years older. And so what we end up with are basically these 2 equations, 2 times the sum right now, B plus P plus J, and then D plus 9 equals B plus P plus J plus 27. That's the plus 9 plus 9 plus 9. Okay, so here is something interesting that's popping out of this. Again, your instinct might be, we need to go back and state the B plus B plus B plus B plus B, 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 B plus P plus J in terms of some common variable. It doesn't matter which. Maybe we go Bill, maybe we go Phil, maybe we go Jenny. I don't know. But we actually don't need to do that, because you'll notice B plus P 5p plus j also pops up right here. And so really, in one way, it's easier to think of this as d equals 2x and d plus 9 equals x plus 27. In fact, we could go and do substitution right there. 2x plus 9 equals x plus 27, x equals 18. Right? 2 times 18 is 36 plus 9 is 45. And on the other side, 18 plus 27 is also 45. So what that tells us is that the original sum of their ages had to be 18. Now, because the question asked how old is Jenny, I do have to go back here and I have to figure out, all right, if b plus p plus j is 18, b plus p plus j equals 18, how do I combine that with this other information? Now, fortunately, b is already stated in terms of 2p, so I can replace that with 2p. Jenny is b minus 2, so that would be 2p minus 2, because of course if Jenny plus 2 is Bill, Bill minus 2, that's the same thing as saying Jenny equals b minus 2. And so then we can say, all right, so 5p minus 2 equals 18, 5p equals 20, Phil is 4 years old. Bill, who is twice that old, must be 8. Jenny is Bill's age. Well, no. Jenny in 2 years will be Bill's age. So Jenny right now must be 6. And as I go back to the question, what did they ask? What is Jenny's current age? Yeah, I would say 6. And as we look at the answers, there it is, 6. Now, that was not super fast. I guess, well, here's what I would say about that. I don't know that there's a significantly faster way to do that, unless maybe we're just really good at guessing. If you see a significantly faster way, please comment down below and let me know. Nothing's occurring to me at the moment. What I will say, though, is this. Although there is this kind of general order of difficulty, both on the sprint round and the target round, just because the questions are intended to get harder as you go along, that doesn't mean there's like a one-to-one relationship, where each subsequent question is always harder than the previous one. So in this case, as I'm looking at these questions, I'm thinking to myself, I can get number 8 done without any equations at all. And again, it turned out to be basically just a proportional kind of question. And so just because 7 is supposed to be easier than 8 in some sense doesn't necessarily mean that it is. And so it's always worth, if you run into a number 7 or a number 1 or a number 3 or a number 5, whatever the first of the two questions is, that seems difficult, just skip it, right? Look ahead, get the other one done, and then go back. None of the questions are worth more points than others, even though there are varying difficulty levels. So we just want to make sure that we bank our points wherever we can. So anyway, there you go. That's target round 7 and 8 from the practice competition 3 for this year's Math Counts practice competitions. Chapter competition coming up. Make sure that you are studying and doing all the things that you need to do to keep those math brains sharp. If there is a question you'd like me to take a look at, or a question from another competition, and you'd like to see a faster way to solve it, or the right way to solve it, or whatever, throw those in the comments down below. And otherwise, I will see y'all next time.